Okay, so AI agents are finally breaking out of the lab and into the real world. We're moving way beyond cool demos and starting to build serious production-grade software systems. But, and this is a big but, this leap requires a fundamental shift in how we actually think about building them. So let's dive into this architectural evolution.
So if you're a developer starting out with agents, you've probably asked this yourself. It's almost always the very first question. You look at a framework like LangChain, which gives you all these great building blocks, and you try to pick an agent type off the shelf, kind of like ordering from a menu. It seems like the logical place to start, right? Well, here's the thing. It's a trap.
Yep, it's the wrong question. See, the problem is, that question traps you into thinking only about prompt engineering and pre-built templates. To build robust, reliable AI systems, the kind you can actually bet your business on, we need to ask a much deeper, more fundamental question about the very structure of our agent.
So really, it all boils down to two core mental models, two ways of thinking about this. On one side, you've got the classic LangChain approach, which is all about a single LLM in a reasoning loop. And on the other, you have the newer LangGraph model, which is about defining a system's topology, its actual structure. And this difference, it's everything. Let's break it down.
All right, first up, the classic LangChain model. Think of it like this. An agent is basically a dynamic loop. You give an LLM some tools, a very carefully written prompt, and it just goes. It enters a cycle of reason, act, observe, and then does it all over again. The agent's type, like ReAct or OpenAI functions, is really just defined by its prompting strategy. The LLM is totally in the driver's seat here. But then, LangGraph comes along and just flips the whole thing on its head. Here, an agent is a structured graph, basically a state machine. You define a persistent state, a set of nodes that do specific jobs, and directed edges that control the flow of logic. The type of agent is defined by its architecture. This isn't just a minor tweak, you guys. We're talking about a massive architectural shift from a kind of unpredictable loop to a super explicit workflow. So, what does this actually mean for us as engineers? Well, the implications are huge. We're moving from what you could call a reasoning-first approach, where we kind of cross our fingers and hope the LLM figures it out, to a workflow-first approach, where we design the system's logic explicitly. Let's see what that looks like in practice. Okay, this table really lays it all out, clear as day. Just look at the control flow row. LangChain is an LLM-driven loop, which, let's be honest, can be super unpredictable. But LangGraph, it's an explicit graph. You get full control. And that pattern just continues right down the list. State management becomes way more robust, determinism goes way up, and orchestrating multiple agents becomes a native feature instead of a clunky workaround. Okay, so how do we actually do this? How do we design our own agent from scratch? Well, instead of picking from a menu, we're going to ask 3 core engineering questions. Think of this as your new blueprint for thinking like a real AI systems architect. Right, here are the 3 pillars of that blueprint. First, what's your control strategy? How does the agent actually make decisions and move from one step to the next? Second, and this one is so critical, what's your state model? How are you going to track information through the entire process? And third, what are the specific jobs of each component, each node in your system? All right, let's double-click on that first step, control strategy. The questions you ask here directly shape your system's architecture. For instance, you gotta ask, is your agent gonna be totally autonomous? A simple loop might work for that. But what if you need a human to sign off on a critical step? Well, now you need a graph with conditional edges that can literally pause and wait for input. This is where you define the fundamental flow of your logic. Now for step 2, state modeling. And listen, this right here, this is where most agents just fall apart in production. You have to stop thinking about state as just a simple, messy chat history. You have to design it like a robust back-end schema. Look at this agent state example. It's structured, it's clean, it's tracking messages, tasks, and even a confidence score. This is professional software design. Which brings us to a really crucial point. And if you take away one mindset shift from this whole thing, please let it be this one. You are designing a stateful distributed system, not a chatbot. The moment you move past a simple demo, that's what you're doing. And thinking this way, it changes everything. And that brings us to step 3, figuring out what each node is responsible for. Honestly, the best way to think about this is like microservices. Each node in your graph should have one and only one clear job. You might have a planner node to break down the task, an executor node to perform an action, a validator to check the result, and maybe a supervisor to route decisions. It's just clean, solid architecture, but for AI. Okay, so that's the theory. But what does this actually look like when the rubber hits the road? Let's check out a couple of really cool, advanced agent patterns you can build using these exact principles. So first up, check out this self-healing agent. The flow is just so logical and robust. A planner creates a step, the executor runs it, but then, and here's the magic, a validator node checks the output. If it fails or if the confidence is too low, it doesn't just crash and burn. Nope, it loops right back to the planner to create a new plan. I mean, how cool is that? It's a system designed for reliability from the ground up. And why is this such a game changer for production systems? Because, most simple agents, they just run blind. They fail silently. You have no idea when they've hallucinated or gone completely off the rails. A self-healing architecture validates its own work. It keeps a clear trace of everything it did, and it actively avoids those silent failures that absolutely destroy user trust. Okay, here's another great example for you. A risk analysis agent for a big company. Notice the controlled flow. It retrieves data, processes it, makes a prediction, and then, this part is absolutely crucial, it hits a confidence gate. If the model is confident, it responds. If not, it automatically escalates to a human expert. This is not some freewheeling agent just trying to figure things out as it goes. No way. This is a controlled, predictable architecture built for a high-stakes job. And look, these are just a couple of examples. The possibilities are pretty much endless once you start thinking this way. You could design a supervisor that delegates tasks to a whole team of specialist agents, or a self-reflection agent that critiques its own work and revises it. The limit isn't your prompt anymore. It's the architecture you can imagine. So this all brings us to the real takeaway here, the main point of this whole explainer. The future of building powerful, reliable AI agents, it's not about prompt hacking. It's about becoming a true systems engineer. While a lot of people are still down in the weeds tweaking prompts, the top teams, they're playing a completely different game. They're up here designing state machines. They're building explicit failure recovery logic, controlling the routing of tasks, and guaranteeing execution. They're not just prompting, they're building distributed reasoning systems. So, the big question, when do you use which one? Well, now the answer should be pretty clear. LangChain? It's awesome for prototypes, for quick tool calling agents, for getting something up and running fast. But the second you need fine-grained workflow control, multi-agent orchestration, and real production-grade reliability, the moment your project gets serious, you need to be thinking in graphs. So if you only remember one single thing from all of this, please let it be this. LangChain defines agents by their prompting strategy. LangGraph defines agents by their execution topology. One is about trying to influence a black box with words. The other is about architecting a transparent, predictable glass box. All right, let's bring it all the way back to the beginning. The next time you start a new agent project, please don't ask, which agent type should I use? Instead, ask the real engineering question. What execution graph does my system require? Because that is how you go from just building a chatbot to actually engineering a powerful AI platform.